All right. All right, remember last time I told you guys to find out what dry ice was?
Oh, yeah.
Okay, what is it?
It's compressed carbon dioxide.
Okay, it's basically frozen carbon dioxide, okay? And then Xander talked about what was unique about it. You want to share that again, what's unique about carbon dioxide? Mm-hmm. You told me it goes directly from what to what?
It goes directly from a solid to a gas.
Right, so what they call sublimes, so it does not melt, okay? And you didn't see any melting last time, okay? So it goes directly from a solid to a carbon dioxide, which is a poisonous gas. Okay. All right, so last time we made some observations about you guys got to do some fun things. Was everybody here from last time? Was anybody? Okay. You weren't here? Okay, so you didn't get to see it. Okay. Last time we got to do some fun things and make some observations. We did tests, we observed, and then we made our inferences. Okay, today we are going to do the same thing with something different. As you see, I've put some dry ice in my aquarium. Okay. We're not going to fill it with water. It didn't say we had to fill it with water. Okay. So what we're going to do is, it's two fun things at once. You guys love to make bubbles, and you love dry ice. So I want you to make some predictions. I'm going to let you guys blow bubbles above the aquarium. I don't want you blowing into it. Okay, so you're going to blow your bubbles above the aquarium, and then we're going to make some observations. So right now, let's make some predictions. What do you think is going to happen when you blow bubbles above the aquarium?
Nothing.
Pop.
You say nothing?
They're going to go in and they're going to pop on the ice.
They're going to pop?
On the ice.
Okay, any other predictions? Okay, let's just kind of leave them alone right now. Any other predictions?
Just drop.
Of what's going to happen to them?
They're going to blow up like boom. Boom. They're going to sink.
Yeah, they're going to sink. So they're going to pop, they're going to sink.
How are we going to blow the bubbles though?
Okay. Now, let's go back over our safety stuff, guys. Remember, shh. I don't want you breathing, since you're blowing bubbles, I don't want you to breathe in. We talked about the gas. Don't breathe in with your bubble or with your straw. We're just going to blow them over the top. You're not going to blow it in. And again, don't touch the dry ice with anything. Okay?
The bubbles are going to expand.
You think they're going to expand? Okay? All right? So we've got some good...
I think they're going to sink because there's no oxygen.
Okay. Wyatt says there's no oxygen in there. How might we test if there's oxygen or not oxygen in there?
Put a gas detector in there and see if they live. Yeah.
Oh, well, we don't have that.
Did you get another one of those?
I did get another one of those. This is Make-A-Wish.
Yeah, this is where I got one.
Red.
Okay, there's some bubble solution there. So I want you to write down with your partner, with somebody, write down what you see, and then we're going to share.
Broke it.
Just like the last time.
They're doing what Wyatt said, and then
They sink and then they pop on the dry ice, so I was right.
Is that a bubble?
It's floating in midair. It was floating and then it popped in the middle of the air.
Come on.
They freeze. They temporarily freeze. No,
Yeah.
they freeze. This one's
Chocolate.
like the first one that landed and it's still here.
Oh wow, they're freezing.
But sometimes they pop in the air.
Yeah, blow them over. Remember, not blow into the container. Blow it over the top.
Wait, don't put your arm through because just use this one. Because
Yeah.
it pops then.
Yeah. Okay, blow it over the top, not into it. Over the top.
How are you doing it so good, Wyatt?
You still can't do it,
No, I
Nate?
can't. Every time we do use this, I can never make one.
You have to do a certain amount of blowing.
I made a big bubble. It's gonna pop.
Stop blowing it. Don't worry, Brian. They freeze. Frick. That'll be a little harder. They freeze.
It's easy. Did you blow?
Okay, see, I think we're blowing into it. We need to try not to blow into
They're floating.
Look, they like float. Wait, is this what they're supposed to do or no?
Well, let's see. Look at that one there that's floating.
It's floating.
Some of them freeze on the bottom.
If you guys see, like you're blowing into it, I don't want you blowing in. I don't want you blowing air into it, like you're doing the same thing. But don't blow the air into it, because see now, look at. If you don't blow the air into it, look and see what happens to the bubbles right there.
They freeze?
No, look at the one.
They float. That's good. We want them to float.
I can't.
The gases are, it's rapidly
I can get lots of
expanding
small
into-
ones.
How do you
See
get
what
to
the
the
bigger
big
ones
ones? Nick, they're actually really easy to get.
I can't even make a bubble.
How do you make the big ones?
Yeah, you
Like this. All you gotta do is blow slowly.
Yeah, blow slow.
It's the rapid gases expanding under it that push it up.
The rapid gases
Oh, I need a
expanding
big
underneath
one.
it.
You're not supposed to blow into it.
Yeah, don't blow into it.
They have
Blow above it.
that are connecting. That big one's all connecting.
Broke
My pop.
Probably because it
I got
connected too
mine.
much.
You popped mine, Alyssa. I worked hard on that.
Look at mine, mine's huge.
Boop, pop.
Sander, that's not funny.
No, it hit
Blow
the
with my
edge.
bubble. It kind of was funny.
That's rude. Don't be blowing bubbles at people.
Then don't be popping my bubbles.
I wasn't.
That sounds weird.
He popped your bubble, but you spit the stuff at me.
There's mine.
That's because I just in general am mad at me. She never liked you.
That's not entirely true.
That's not
Okay,
That is false.
all right, look at that one right there.
They look like
That was
paper
you?
bags. They look like paper
Ryan,
bags.
you're blowing into
Yeah.
it.
What?
Blow
Okay,
above it. not
Ryan, don't blow into it, above it.
Don't blow into
Because
it.
now look what happened to all the bubbles. What did you do when you blew
They
into
look
it?
like paper bags.
Pop them.
Stop showing off.
See, he blew it too big. I can make small bubbles, just not big bubbles. I can make
We're
both.
probably going to have to wait a minute because Brian blew all the...
Oh, they actually are. That's funny when it was turned the other way.
Stop showing up, Brian.
Yeah.
You know, just for showing off. Yeah.
Unfortunate, I can't make bubbles.
Alright, I know what.
All right, so fine, go with your partner. I want you to write down what you saw, and then I want you to explain what you think happened. And then
I can't get any big bubbles.
I guess I made it.
I gotta go until I get a big bubble.
then I will tell you if you're wrong or right.
I already told you what I thought, though. Am I right?
There's some pencils right here,
Like Xander
and
said,
then
go straight to
Can I
the
go in a
gas.
group 3?
okay, yeah, that's fine.
Yes.
Yeah, that was fine.
Then
Bottom and then back up.
write down one question you have, and then maybe a way that we could test your
Judgment.
I made multiple.
inference.
Nate, look. I made a bubble too.
Okay. Okay. So write down, ladies. You have yours. Everybody. Anybody else need a pencil? Wyatt, let's just keep that off right now. When we do our other experiment, you have a pencil?
Hey, are you guys free?
Okay, let's take a break. Time out. We'll come back to the dry ice.
I'm trying to make bubbles.
I want you to write down what you saw and why you think it's happening, and then a way that we can test that.
Okay, we're heavier, so it goes
Okay,
down.
write it
Goes
down.
up.
Write it down. So you should be discussing with your group what you think is happening.
Mystery of floating bubble.
Yeah, I made a big enough bubble. I'm counting that. I'll
Okay.
take that.
Mystery of not floating
Okay,
bubbles.
what did you say?
Can I try a guess?
What?
Can I try doing a guess again?
I said
Desk.
Like we did first day when we were here.
Oh, no, because maybe when we're done.
all right. That's what I think.
Okay, now, tell me how we're going to test that, Xander. How would we test it? You and your group should be...
Bubbles and dry ice.
Oxygen pump.
Oh no!
So,
Oxygen pump.
what do you think? Cole? Do you agree with that?
Wait, what was it?
Alex, do you agree with their inference?
It says H2O is heavier than the carbon molecules, and the way we can test that is with a giant oxygen pump.
Okay, what about something that we might already have here that we could test it? You're blowing in, Xander.
Oh, I know this stuff. Oh, I know. We might want to watch it.
One of these.
Okay?
This
Gases are pushing up on it, and
Uh,
how could
I
we
dropped the air out.
how could we test that?
we could put water in it so that we can see that the gases are forcing it up.
Okay?
This is easy.
Brian makes a little mess.
All you gotta do is go like this.
Can we get Jolly Ranchers too?
Okay, we'll see. I want to see, I want to listen to your,
You guys.
there's one right there.
You suck!
Okay, shh.
That was not
Alex.
mine. That was Alice's.
What did you do?
Okay, everybody got an inference.
Pop my bubble.
Okay, all
Oh,
right,
I
gentlemen. Okay, let's calm it down. I want to hear everybody's inference, okay? All right, first of all, what were some... Okay, so let's stop blowing a minute because we're gonna test some things. Stop blowing.
mean, stop blowing.
Yes.
Okay, so what were the... Let's first of all, what were the observations we made? What were the observations we made?
The bubbles were floating.
Okay, the bubbles floated in the air. Okay? Now, what was you guys' inference? What do you think's happening?
And carbon dioxide is like on the bottom half, and then the oxygen's on the top, so it's making the bubbles can't enter.
We
with
think the
carbon
opposite.
Okay,
dioxide, so it's like sitting on the...
We did the
Okay,
opposite.
gentlemen, stop just a second.
Yeah, Alex.
Okay? All right, so tell me again.
There's oxygen on the top and carbon dioxide on the bottom, so it makes the bubbles float in the middle because it can't get past the carbon dioxide because then the oxygen wouldn't be with it.
Okay? All right, what did Wyatt, what did you and Nick think? Or Nate think?
That the gas is expanding under it since it goes straight to a gas, or pushing it upward. And
Okay?
how we could test that is like put water in it so that we can see the gases expanding.
Okay. How were you guys going to test your theory? What did you have to test yours? Okay, think about that a
We did
minute.
the same thing, except we thought that the oxygen was heavier than the carbon.
Okay, so you think the oxygen's on the bottom, the carbon dioxide's on the top?
We could either use one of these eyedroppers, we could like get the oxygen and like the air like
Okay.
push it in there like that, or we could get a giant oxygen tank.
Okay, how might we, before we do the water, how might we check to see if there's oxygen in there?
Yeah, like
Magical unicorn. Isn't there like that gas thingy that you can do?
It turns into ice. Look at that.
The frozen bubble.
Okay, I don't have, there are, but I don't have one. Something very simple that I might have that would check to see if there's oxygen in there.
We
No?
We have one. You say it. But then how do
Okay.
the bubbles stay on the bottom? I did not. You came up with it.
Okay?
They break the bottom in case there's carbon dioxide, and then we can make it if you
Remember, we are not using any human subjects. I'm not going to have anybody breathe. Remember, what was my safety thing? Do not breathe the gases.
No, you're in the air, Brian.
Okay, I'm thinking of something very simple that needs oxygen besides us. Fire.
An animal.
So could I light a match and see if...
Can I light it? Can I light it too? I want to light a match. Then
Now-
we can do it for ours.
This gives you a minute to put bubbles while I... Don't blow, but do not blow in there, okay? I'm going to go get a match and we'll see if that works. I couldn't remember where I kept my matches. All right, so...
Right now, we need to stop.
All right, so nobody's blown in it,
I'm
right?
gonna punch him in the nose.
Okay.
Yes, they just did.
Well, no, they. Yeah.
Oh, oxygen.
No oxygen.
no
Like the-
oxygen.
Here,
Just
let's
drop it
let's
in
try-
there.
There's
Drop it in there.
oxygen. Look, it lives.
Drop it in
Then it
there.
Don't drop it in there.
Okay.
'Cause now you can't get it
Wait,
out.
I don't get it. But as soon as it goes over it, it dies. I mean,
Okay,
It
so...
has no
Drop
oxygen.
one in.
But why?
Get it all the
why
way
is
to the
it
bottom.
called- Like
It has no oxygen.
you can see the little
Okay, so I'm here.
clouds.
Okay.
Yeah.
Drop it all the way to the bottom.
Yeah, you
No,
might burn
and
your
the
finger
yellow's
if
getting
you...
lighter, so it's not getting as warm.
Okay, so when does it go out?
Right there.
Right there.
And
inside the
Tank.
tank, okay?
Drop one
So what do
match
you
in.
think is happening here?
Drop a match always in.
There's not enough oxygen.
Okay?
The oxygen has to go to the bottom because the oxygen, because it's dying on the top, but the oxygen has to be on the bottom, so the oxygen has to be heavier.
You want to try
Because
it?
the oxygen has to be on the top for it to be.
Okay, so do you want me to see if I can get it all the way down there?
Yes.
Can I try it?
No, put two cups
Okay.
together.
Can I try it?
No, 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 no,
That's
no.
not safe.
Yeah,
So-
that's not safe. That'd be on fire.
Yeah, I can't get it down there.
What if you
drop
drop it? Yeah.
Just drop it. Maybe
Bubbles
it'll go
have
down
no
Okay.
air
at
left.
speed.
The bubbles have no air left.
It dries too fast still.
Okay, so what's your inference?
The carbon's
The carbon dioxide.
Fills it up.
Since the bubbles
Like you-
freeze,
like, look,
since
you
the
can see
bubbles
the-
freeze,
the
there's no more air
carbon.
left.
So you know that the bubbles are froze down there, so there's carbon dioxide down there too,
Since they freeze,
right?
there's no more.
Yeah, hey, look, look at this.
Stop showing
When Brian blew it up, the bubbles didn't go past the fog.
Yeah.
Yes, another good bubble.
It stands right there.
Okay.
That means there's oxygen.
Well,
in the
you guys saw what happened last time when we put the ice in water, right?
Yeah.
What happened?
It makes bubbles. It
Okay.
goes up.
The carbon dioxide basically is replacing the oxygen in there. So there is no oxygen in there. That's why the match is not lighting. So, okay. Now, why I wanted to put some water in there. What do you think the water will do?
Make bubbles and
Wait, let's put hot water in there. It'll make
You
it
want to put
stable.
I
hot
like
water?
cold because that makes bubbles. Remember?
Okay. Let's just put,
Let's put it in.
we'll just put a little bit of water in there and see what happens.
Hot water gives more bubbles.
Do hot water, not cold water.
Hot water gives more bubbles.
The hot water makes more steam.
Okay, do you want to blow some bubbles in there now and see if it does anything different?
Hot.
Hot?
Go, 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 go.
See if it makes any difference with the water in there?
Later, you suck. They just fall down and die.
This fall down.
Okay, so it's not doing anything differently.
They don't float anymore. No, it enables us to see the gases.
When one of them popped, it froze right
All
up.
right, so it's still working.
Yeah, you can still see some of the gases up top of the bubbles. Are
When one of them popped, it froze right after.
Really?
My bubble's still alive.
So do you think it's better, worse with the water?
I think it's better.
Yes.
Better?
It's still alive too.
I think it's
You think it's the same?
More bubbles are floating with the
Pop on the
water.
side.
It might be the same.
That means there's more.
Now do hot water.
Hot
Yeah,
water, yeah.
because water has H2O. That's why more bubbles.
Put the hot water in.
Okay, Nate says water is H2O.
Yeah.
Hydrogen.
You might want to try
Don't
that.
put your hand in there. You'll freeze it off, and then we'll all be happy.
What?
So actually, feel free to put your hand in there. Then they'll lose it, and we'll all be
Yeah, I was
happy.
gonna say you just.
Dude, it's touching the dry ice and nothing happens. Until it just froze right there.
Oh, that one's still frozen.
I made bubbles.
Oh, you just.
Okay, so you guys have brought up, you think that warm and cold water make a difference?
Oh, Mr. Sen.
Yep.
I saw one of the bubbles, like, it just lost all its air, like right when it
Yeah.
froze.
Really? So it just went, all right, so I've got a quick little, about 15 minutes of a quick little activity. You can try the hot and warm. So, with your partner,
Can we bring our bubble solution with us?
Can we please grab some?
okay, let me get,
Where's the experiment?
I'm gonna just.
Where's the experiment?
okay,
What's it called?
Don't hurt Addie.
so there's your cups. There's your cups. Here's the hot water. And then the ice is in here.
Regular ice?
Dry ice for pieces. Probably need some smaller pieces in there, don't
Cold
I?
water in here.
Oh, can I smash it?
That one's a big one.
Okay, that's good. Now we add the cold water.
Plate and we'll go over to
Can I get one now?
Bring the sub solution.
Can I get one?
Remember to try to get two pieces that are the same size. No.
2 pieces?
Use the taller cups, guys. Use the taller ones. Yeah.
Sander.
Okay.
Over there.
Read your instructions so you know what you're doing.
I'll grab the
Okay, did anybody read their instructions before you started going?
the bottom.
What?
Did anybody read their instructions before they started going?
Grab one of those.
No.
Put yourself at the bottom first.
Read the instructions before you guys start going.
Get another cup and then you can pour it.
This is just
Let's keep that away. Let's move yours. Did you guys read your instructions?
Awesome. It blows the air when you go like this.
No, watch.
Hey,
We're gonna have to get
I can't do it.
can I
Watch this. You move the air.
Okay.
No, watch, Alex.
Now here, your soap's in there.
Can't we use this?
I guess you could probably use that. It would be a little more diluted, but diluted means there's not as much soap. It's mixed with water.
Yep. Okay, I got him.
You should be trying to get them as close as you can in size.
This isn't on.
It's
drop it.
should be still working.
No, Nate, put that back. 1, 2.
Actually, you can do it.
Yeah, go ahead.
I can't move those. That's not.
All right, I'm gonna have guys.
We're waiting for that to.
But this is remember this is what you're supposed to have done.
Yeah. All right. Let's just do it in
Okay.
the cold water, okay?
You're supposed to do one in cold, one in hot.
Let's just experiment with the cold water. No. That's good.
And then make your observations.
Hold on. No, Nate.
Why does it make a sound? Why does it make a farty sound when I touch it?
It's vibrating, I think, because it's so.
We did that last time.
Remember what happened when I put it in here?
Where's the cold?
The cold water's in this cup right here.
I forget this was.
It's over here. Calm down.
I forgot this was on the.
Yeah.
It was kind of just
Yeah, don't use all the hot water because that's all I have.
Ready?
I may need to send.
Wait, no, don't put it in.
Well, I'm in trouble because Wyatt used all the hot water.
We got ours, right?
We have ours.
Okay.
Ready? We'll
Did you guys get hot water?
It's all me.
That's the cold water. Our hot water out kind of messed up.
Okay.
I cleaned the dry ice.
Don't put in the dry ice yet because we have to put it
Actually, I'll
on
put it in dry ice. Remember?
Good?
Last time.
Can I grab it? Okay. Yeah.
That makes a big difference.
No, we need more dry ice now. I've had a dry ice.
So that's your hot and this is your cold or hot, cold? Okay, did you have soap? You had soap in that one too?
Oh, this is small. That piece of dry ice.
Okay, remember you're supposed to use the same size?
No, these are ours.
Are the boys going to buy us?
Yeah.
All right, so I'm going to see how this works doing it the right way.
We're doing it, right?
The right way.
No, they're not.
Whoa!
We just guessed.
That's like the same time as last time.
Hurry up.
Oh, we did the same thing. That one just.
So-
About the same? Yeah.
So which one?
Is this?
So which one looks like it's going better, the hot or the cold?
Mine's hot.
If you
Hot.
touch the bubbles, it. Cool.
You guys want to move those computer? Remember I told you to move those computers away from the stuff. Yeah. Want to move that one away? So this is the hot, or did you just add more?
That would be the hot natural.
Okay, so what you're saying is the hot works better than the cold?
The hot bubbles are a lot bigger bubbles.
Okay.
One big pop makes.
This one, yeah, because that one's more water.
All right, and so which one yours work better? The hot or the cold?
Hot.
Okay, so the hot work better?
The hot makes
But you
bubbles.
can tell that it goes into the gas.
Oh, that's cool.
Yeah, we're magicians.
Cool.
Okay, cool. At least a little.
I didn't even know that it would do that.
Yeah, we just started touching the bubbles because we did that.
Did you guys see what these girls are doing? They're grabbing it in their hands and it disappears.
It goes into gas.
You can
Well-
touch the bubbles. Bubbles are more normal.
Wait, stop. The bubbles are. That's the little one. Let me worry about the big one.
Yeah, maybe not in somebody's face though.
Yeah, because it still has carbon dioxide
Yeah.
fumes.
Oh well.
So you could kill Wyatt. But
Yeah,
you could kill
Turn
Wyatt.
that a bit, some of this.
all right, so what I'm seeing, tell me if I'm not correct, that the hot water made more bubbles than the cold water.
Oh, yeah.
Okay.
Oh, I'm next on that.
So nice.
You gotta pick a different
Oh, we're putting out.
Wait.
Okay, any idea why you think the hot's better than the cold?
I said this last time. There's such a change.
Okay, Wyatt said because there's a greater temperature change.
This is so awesome.
Well, after Alyssa.
Yeah, that's cool.
Wait, can you grab my?
Yeah, if you want to try it again, you can try it again.
You want to try it?
We got plenty of dry ice.
Put them in the other ones.
You can also grab some out of here.
Dry ice at the top.
Why I gotta do it?
Careful that you don't hit the cup, though.
Addie, let's get
Oh, we have to get some from out of there.
Addie, let's get some dry ice and just add it like we did last time.
Yeah,
I can do an experiment with. Let's see if I can do it. There's a thing I can do that's crazy.
let's see. Let's see if it's given us any other ideas for activities here.
Can I put a piece of dry ice in this balloon? Like, can I just put a piece of dry ice in the balloon?
I don't care.
Brian?
All right, so
I'm gonna use these.
Hey, I'm gonna help you.
Ours is making bigger. Right, cool.
I'm gonna help you guys figure out.
Aspen, toss the big bubbles. Watch. I can't do that without a piece of what?
Oh, that's a big piece.
yeah, you want to grab that out of there for me?
Oh my god, I want to be Batman.
All right, so Wyatt's explaining it that there's a bigger temperature difference between the two. Do I have any other ideas?
I'm more like
Nope?
I think we're
Yeah.
I'm Batman.
You are definitely Batman, Nate.
No, Nate, you gotta do it right. We gotta get like just plain water.
I'm not even sure I know what the answer is to this question. Let me see if it tells me what the temperature does.
Oh, it was even right.
Wow, that was sucks.
Hey, Aspen, grab some more soap.
Look at this.
So good.
Well, I think we need more soap.
Excuse me, we need a piece of giant dry ice.
It's a good thing it's dry ice, since you guys are making a mess.
Put another one in there. Because this one's our favorite.
Okay.
Wait, what?
There's another piece of dry ice over by someone's foot.
Sure.
I'm leaving this area.
How,
So everybody, watch out.
how might we measure this? You guys have just observed and used your eyes, but how might we measure it to get a more quantitative?
That's not good.
How much is it? Just beginning?
Okay.
measured that.
What else might we measure?
The exact pieces of dry ice.
Okay, exact pieces of dry ice. We could weigh them.
water.
And water. Yeah. Because we're just doing it by observation, but if we really wanted to know, we would want to measure everything.
Yeah.
Exactly.
Alyssa.
So
Can we touch this dry ice since it's been in hot water?
I wouldn't touch it.
One more drop. Look at this.
I would not touch it.
We're making the mind blink.
Okay, so what do we got going on? What are we putting here?
Bubble solution, water, and dry ice.
Just
Okay.
a little bit of dry ice.
A lot of dry ice. Is that what we did?
Just
Yes,
a little bit.
basically.
Okay.
Yeah.
Okay, I think you have enough in there. This one,
I was
definitely.
talking about over there.
All right.
More over there.
I was talking to them. How might we? Because right now you're just doing it by observation. How might you do this more scientifically so we know exactly if
Measure everything.
measure everything? Yeah, and yeah, probably safety. But you would
Everything
want.
has to be the exact same.
Yep.
Exact same dry ice.
Yep.
Exact same water.
It's like
Okay.
you just buy something from the store, dry ice, split in half, and you play by beef, it's not right.
Well, we would weigh it. We've got our triple balance. We'd weigh everything to be exact.
Everything has to be exact.
And then how might we measure then which one works better?
By counting how many bubbles are made in seconds.
You time it right and see what.
Okay, time it. Okay.
Might manage to get them both in at the exact same time.
And
Hot
time
and
it.
cold water.
Okay, I didn't ask these guys.
Mix them together and then add the bubbles.
Okay, we talked about how we'd have to measure everything, but then how did we determine which one works better?
The one that makes the most bubbles.
The first
Okay,
one
but
that
how would
falls
we
over.
determine that? Because remember,
The
without,
first one that falls
So
over.
first one that the bubbles fall over.
Because they go up and then they fall over.
Because once they get to a certain height, they fall.
okay. So, but is that going to be exact measurement? Okay, how might we do an exact measurement?
I don't. You measure how high the bubbles.
You could measure how high,
How big?
okay? They also put a time on it, like how quickly they happen. So you could maybe time it too.
I think when we did it, he put his in and they were getting up here and mine. I put mine in about 6 seconds later and they're already.
Okay, so you would maybe have a ruler or something next to it.
more bubbles than that one, which bubbles also affect it.
See how high we can get it.
Let's put some more bubbles.
That was cool. Watch this.
Okay.
My dad did that.
Okay, are there any questions you guys have about the dry ice?
Nothing ever got to do dry ice with us.
Any questions here? No questions? You guys know everything?
Yeah.
All right, because we could test something. Okay, any questions here? Okay. All right, then I think we are done and we need to start cleaning up.